Hello, so this is a revision video for AP Chemistry 1.2, Mass Spectra of Elements. Many elements in nature exist as mixtures of isotopes. Isotopes are atoms of the same element but with different masses. Mass spectrometry is a technique used to separate and measure the different isotopes in a sample of an element. The machine used in mass spectrometry, a mass spectrometer, produces a graph called a mass spectrum. The x-axis shows the relative mass of the samples being detected, and the y-axis shows the relative abundance of each isotope in the sample, usually as a percentage. Each bar in the graph represents an isotope of the element. A taller bar means the isotope is more abundant and has a higher relative abundance. Exam tip here: if you are given a mass spectrum with just bars and no percentages, you can treat the bar heights as relative values, add the total height of all the bars, then calculate each bar's percentage as a fraction of the total. The mz value just refers to mass to charge ratio of the ions being detected. Because the charge of most ions in mass spectrometry is only 1, then this simply means mass divided by 1, so the mz value actually equals the relative mass of the samples being detected. Don't worry if that seems a little bit confusing. Because in AP Chemistry we only focus on single charged ions in mass spectrometry, each peak in a spectrum represents a different isotope of the same element. Average atomic masses given by a periodic table of elements aren't simply averages based on isotopes. They're weighted averages that reflect both the mass and natural abundance of each isotope. To calculate average atomic mass, we use the formula average atomic mass equals isotope 1 mass times its fraction abundance plus isotope 2 mass times its fraction abundance, and so on. For example, if a sample of chlorine contains two isotopes, 34.97 with an abundance of 75.78 and 36.97 with an abundance of 24.22, we can convert these abundances to decimals, so 75.78 equals 0.7578 and 24.22 equals 0.2422. We can multiply these decimals by each isotope's mass to give the relative atomic mass overall. So 34.97 times 0.7578 equals 26.5 plus 36.97 times 0.2422, given 35.46 in total. So this would be the average atomic mass of chlorine.